Hello everyone, my name is Salim Shiraj, and today I'll be presenting my honor assignment project on how we can use linear algebra and matrices to balance chemical equations, and how this can be implemented in Python. The idea is to show that something we usually think of as a chemistry problem can actually be solved very systematically using maths and specifically matrices and system of equations in Python. Okay. Okay, so let's go on slide 2 and why balance equations. So let's start with the basics. We balance chemical equations because of the law of conservation of atoms. The number of atoms of each element must be the same on both sides of the equation. For small equations, we can often do this by inspection, but for larger and more complex reactions, manual balancing becomes very difficult because of the size. So, in industry, this become very critical because balanced equations determine yields, cost, and emissions. For example, in power plants, in factories, or in environmental studies in general, balanced equations allow engineers to calculate exactly how much input material is needed and how much waste is produced. Now, let's go into slide 3. From chemistry to math. Now, let's connect chemistry to math. To balance an equation, we assign variables to the coefficients for each element. We write one equation that ensures the number of atoms is the same on both sides. Uh, so every element contributes to a linear equation. Finally, we stack all these equations together into a matrix equation. Here is the balance matrix, and this is the vector of coefficients. The goal is to find a non-trivial solution for all of this. Okay, let's go to slide 4. Now we're going to see an application of the method we saw previously, and we will take the propane combustion equation as an example. Okay, here we'll start with the unbalanced equation of the propane combustion, and if we assign coefficient, we can write equation for each element. Here, this is the equation of carbon. As we can see, we wrote 3 here because we had 3 here, and for the hydrogen equation, we wrote 8 as a coefficient and 2 because on the left side here we have 8 and on the right side here we have 2. And the same for oxygen. Here we wrote it like 2x2 because here we have 2, and we wrote it as 2x3 because we have 2 here, and we wrote a plus x4 because we have, oh sorry, because we have an atom of oxygen here. And this equation will form a matrix system as we can see here, and you can see like we have 3 0 minus 1 8 2 and 2 minus 2 and minus 1 here. So the matrix is according to the system of equation here, and if we solve it we will find the following ratio. So the balanced equation is C3H8 plus 5O2 will yield to 3CO2 plus 4H2. So this shows how chemistry transforms into a math problem, and how solving a system of equation can give us the balanced results. Now, going on slide 4, we will generalize the method. So, the first step is to build the balance matrix. Row are elements and columns are species. And the second step is solving the homogeneous system. This means finding the null space, which give us the ratio of the coefficients. And the third step is to scale the solution to the smallest positive integer. This guaranteed the reaction is balanced systematically, and no guessing is needed. Now we'll pass on to the Python demo code, and I will show you how to implement this method in Python and to automate it. Yeah, and we will test the code with some examples, and this will show that the matrix method scales from simple to very complex reaction when we will combine the power of computer and the power of maths. Okay, now that the code is built, I'm going to first explain it, then I'm going to solve some equations, chemical equations with it, so you can see. So, first, we have the first function, pass formula. It takes a chemical formula like C3H8 or H2O, and convert it into a dictionary of atoms. So let's take an example with the C3H8. The string C3H8 is going to go inside the function, and the function will return a dictionary like C 2.3 and H 2.8. So this is how the program understands what elements are inside of each molecule. And after that we have the second function, build matrix. So this function takes the full equation and it splits it into a left side and a right side, and then it builds the matrix. And here each row represents an element and each column represents a molecule. Reactant are positive, and reactant are positive and products are negative. So basically this function is building our matrix A. And then we have the third function and the final one. This function puts it all together. It finds the null space of the matrix using SymPy, and it gives us the ratio of the coefficients. Finally, it scales them into integers and print the balanced equations. So now we will test the code for the following equation. First, the propane combustion, then the glucose respiration, then the thermal reaction. So for that, we will need to build a new cell, and then we're going to copy and paste this to be easier. And we're going to do print to show the results, and then we're going to call the balance function and we're going to do that for each one. So for that to be easier, I'm going to copy and paste. and then we will run it all. So as we can see, for the propane combustion, it gives C3H8 plus 5O to 5O2 yields to 3CO2 plus 4H2O. And for the glucose respiration one, C6H12O6 plus 6O2 yields uh, to 6CO2 plus 6H2O. And for the final one, the thermometer reaction, we can see that for it, two aluminiums plus one iron, 2O3 yields to one aluminium, 2O3 plus two iron. And that's it. In just a few lines of code, Python can do systematically what would otherwise take us a lot of trials and error, and with an unprecedented speed. And this shows the real strength of the matrix method. Once you write as math, the computer can handle any exam, big or small. For example, we can have very large equations, and it will still be solved in a few seconds. And now I'm going to conclude. So we will look at why matrix balancing matters. So first, the application in industry and for process optimization and cost calculation. Also for environmental applications like in science for modeling emissions like CO2. And also we're going to see the advantages. It is systematic and scalable. It works for complex equations where manual balancing fails. It's computer friendly, and it builds a direct bridge between chemistry and mathematics. And so the big takeaway from all of this project is that it demonstrates how a real problem from chemistry can be modeled and solved with the aid of linear system of equations using a tool like Python. Thank you for listening to me. This is the end.